This video covers Section 6, Authoring and Configuring Lambda Functions. When you create a Lambda function, you specify the function handler. The Lambda function handler is the entry point that Lambda calls to start running your Lambda function. The handler method always takes two objects, the event object and the context object. The event object provides information about the event that invoked the Lambda function. This information could be a predefined object that an AWS service generates, or it could be a custom user-defined object. A user-defined object could be a serializable string, such as plain old Java object, also called POJO, or a JSON stream. The contents of the event object include all the data and metadata that your Lambda function needs to drive its logic. The contents and structure of the event object vary, depending on which event source created it. For example, an event that API Gateway creates might contain details that are related to the HTTPS request that the API client made. The details might include path, query string, and request body. However, an event that Amazon S3 creates would include details about the bucket and the new object. The context object is where AWS generates a context object and provides runtime information. The context object enables your function code to interact with the Lambda runtime environment. The contents and structure of the context object vary based on the language runtime that your Lambda function uses. At a minimum, the context object will contain three methods or properties. The first is the AWS request ID. This property is used to track specific invocations of a Lambda function. This is important for error reporting or when contacting AWS support. The second item is the log stream name. This is the CloudWatch log stream that your log statements will be sent to. The final item is the getRemainingTime in millis method. This method returns the number of milliseconds that remain before running your function times out. This is an example of a Lambda function that is written in Python. It defines a handler function that is called Lambda_handler. The function returns a message that contains data from the event that it received as input. Notice that each language has its own requirements for how a function handler can be defined and referenced within the deployment package. This slide shows what the example from the previous slide looks like if you write and test it by using the Lambda console. Memory and timeout are configurations that determine how your Lambda function performs. These configurations affect your billing. With Lambda, you are charged based on the total number of requests across all your functions. You are also charged based on the duration, meaning the time it takes for your code to run. The price depends on the amount of memory that you allocate to your function. Memory refers to the amount of memory you specify that you want to allocate to your Lambda function. Lambda then allocates CPU power that is proportional to the memory. Lambda is priced so that the cost per 1 millisecond of function duration increases as the memory configuration increases. The timeout configuration allows you to control the maximum duration of your function. Using a timeout can prevent higher costs that come from long-running functions. You must find the right balance between not letting the function run too long and being able to finish under normal circumstances. One best practice is to test the performance of your Lambda function to make sure that you choose the optimum memory size configuration. You can view the memory uses for your function in CloudWatch logs. Another best practice is to load test your Lambda function to analyze how long it runs and determine the best timeout value. This information is important when your Lambda function makes network calls to resources that might not be able to handle the scaling of Lambda functions. Lambda offers several resource-related configurations, such as how Lambda interacts with other AWS resources to adapt to different use cases. For example, you might need to connect to a virtual private cloud or VPC, an Amazon Relational Database Service, also called Amazon RDS, instance, or an Amazon Elastic File System, also called Amazon EFS File System. You can also configure details that are related to event sources, such as destinations, and asynchronous invocation details. Both types are relevant to asynchronous event sources. Destinations can also be used for streaming event sources. You can also configure AWS step function state machines that can directly invoke your function in one of their steps. Code-related configurations are also available. These include the runtime that the function will use or language that the code will be written in. You can specify environment variables, which are key value pairs that are accessible from your function code. You can configure tags, which are labels you assign to an AWS resource. Each tag consists of a key and an option value. And you can use code signing, which ensures that the code has been signed by an approved source and has not been altered. There are a few best practices to follow when you design your Lambda function. First, treat functions as stateless. Don't save any information about state within the context of the function itself, because your functions exist only when your work must be done. It's important for serverless applications to treat each function as stateless. Second, include only what you need. Minimize both the size and the dependencies of your deployment package to reduce the startup time for your function. For example, choose only the modules that you need, such as the DynamoDB and Amazon S3 SDK modules and the Lambda core libraries. Don't include an entire AWS SDK library in your deployment package. Along with this, reduce the time that it takes Lambda to unpack deployment packages that are authored in Java. And minimize the complexity of your dependencies. Choose simpler Java dependency injection frameworks. For example, choose Dagger or Juice instead of more complex frameworks like Spring. The last best practice is to reuse the temporary runtime environment to improve function performance. This environment initializes any external dependencies of your Lambda function code. Make sure that any externalized configuration or dependencies that your code retrieves are stored and referenced locally after the initial run. Limit reinitializing variables and objects on every invocation. Keep alive and reuse connections such as HTTP, database, or others that were established during a previous invocation. There are also best practices for writing code. First, separate the core business logic from the handler method. This makes your code more portable, and you can target unit tests at your code without concern about the function configuration. The second best practice is to write modular functions. Create single-purpose functions. Third, include logging statements. Lambda functions can and should include logging statements that are written to CloudWatch. The fourth best practice is to include results information. Functions must give information to Lambda about the results of their run. Next, use environment variables. With environment variables, you can pass operational parameters and configuration settings to your function without making changes to the code itself. For example, if you are writing to an S3 bucket, configure the bucket name as an environment variable instead of hard-coding the bucket name. You can also use environment variables to store sensitive information that the function requires. Another best practice is to avoid using recursive code. Avoid a situation where a function calls itself. In this circumstance, it might continue to spawn new invocations that would cause you to lose control of your concurrency. And finally, don't call one function from another. Instead, use destinations or orchestrate with step functions. Higher memory configurations have a higher per 1 millisecond cost, but might decrease duration costs and concurrency needs. For example, with applications that are CPU intensive, increasing the memory, which provides more CPU, can shorten the duration of the function. Therefore, it might be cheaper to run it at the higher memory level. Use the power tuning utility to find the balance that suits your application needs. Here are the key takeaways for this section of the module. Lambda supports different languages and runtimes. The function handler is the entry point into the Lambda function. You can configure attributes, including the amount of memory and function timeout. Follow best coding practices to create efficient Lambda functions. Thanks for watching. We'll see you in the next video.